Thanks very, thanks very much, TJ. And thank you to all of you for signing up to come along and listen to me. It's a really large group out there. It's very humbling to have the opportunity to talk to you all, and hopefully we'll cover some stuff that maybe you hadn't thought about in these ways, but I'm sure it's going to be familiar to you all. As TJ says, I've been working in evidence synthesis since about 2011, 2012, formally, although I'd done literature reviews, systematic reviews, as I thought before that. And that's relatively soon after the Collaboration for Environmental Evidence was established, which was 2008. And I started working at the Centre for Evidence-Based Conservation. Um, and a lot of my experience of evidence synthesis has been in a new discipline where evidence synthesis methods were emerging, but particularly where for that discipline, the standard practices in the mainstream that we were learning from, which was health, um, needed a bit of massaging to work in environment because we're dealing with less evidence, messier evidence, and often very diverse evidence, um, and constraints as well. During my PhD, I worked on an endangered species, and the sample size of a lot of my work was one because of that. And so I have had a lot of experience of trying to make things work in different scenarios. And I think the aspect of evidence synthesis that I find the most interesting is trying to apply traditional methods to a novel topic, to a novel set of constraints, and trying to make it work. So, what I'm planning on talking about today is, as TJ says, open synthesis. It's the application of open science principles to evidence synthesis. I do feel this is something that we're inherently more aware of and more open to, because of the need for openness in all of the primary research that we're dealing with in a systematic review. So often we get frustrated by some of the challenges that are caused by closed primary research, making it very difficult for us to access the full text, extract information, obtain all of the necessary data for our analysis. And so I feel like we have an opportunity and an obligation as secondary researchers to really lead the field in terms of being open, and how, for anybody who's done systematic reviews, knows they're very complex, very long-winded, very detailed processes. And so making sure that we are open enough that other people can use our data, but also that we do it in a way that is friendly to ourselves, because these projects can take often several years. So planning ahead and being as open for our future selves has that somewhat selfish benefit as well, to make it easier for when we come to write up. Um, so what I wanted to talk about today was firstly, what is open science for anyone who's not aware of it, and what are the pros and cons of open science as deemed by the wider community. We'll talk about the sort of status quo of closed evidence syntheses, and what's wrong with closed syntheses. And then we'll talk about what open synthesis is as a principle, why it's needed, what the benefits of it are, um, as well as some of the criticisms of open science. It's not without its criticisms. It's been quite heavily criticized, actually, and how those criticisms relate to open synthesis as a concept. And then how we, as a community of practice, can move towards more open synthesis. That means making things easy and making things feasible, and then making them ideally compulsory. And then some practical steps for us as individuals to make our reviews more open. And so throughout this process, I'm making some assumptions that we appreciate why openness is important for rigor, but we'll be diving into some of those assumptions. So open science has been discussed in lots of different flavors, lots of different frameworks. And it has a range of different components, from the more simple ones. This is the ASAP Open Science framework, that's now over 10 years old, talking about open educational resources, open access to research articles, open peer review, open methodology, open source software, and open data, um, before it's or as it's analyzed. Um, some of these aspects of openness might be relatively new to you. Some of them are in wide use now, I'd say. So open access is pretty mainstream. Some of them are a little bit more niche. Open methodology is something that really is only just starting to be applied. Open protocols and registered reports being two examples. Um, and then there are some incredibly complex versions like this taxonomy from Foster Open Science, that breaks some of those down into narrower components, but the broad um, themes are the same. So we've got open access, we've got open data, open reproducible research is around method, a combination of methodology and data really. Um, and evaluation being things like peer reviews and metrics. But there are some additional ones in there that I'm sure you won't have really heard of, like open science policies. But the general theme around this whole set of frameworks for open science is that we should be making the science that is publicly funded accessible to our public. Um, Beyond open science, there are also FAIR principles which overlap very heavily, but they're more about um, principles behind openness, not just putting it out there, but also thinking about making it as usable as possible. So the FAIR principles, it's an acronym. F is findable, so they should be easily findable. It's not okay to just put them online and not have them indexed or easily found by a user who needs them or wants them. Um, Accessible means making it providing it in a way that can be accessed. So we should be using file types that are long term. One example of this is early systematic mapping used Microsoft Access, which now is not widely used by anyone. Um, Interoperable is that things that we put out there, sort of related to that in a way, that things that we put out there should be in a format that allows us to put them into different programs and use them in different ways. And reusable, meaning that they are in a format that can be reused. So these are a little bit more nuanced as they apply to each aspect of open science. Um, and there are obvious advantages to open science, which is why the movement is so strong. That it allows for rigorous peer review. Um, there's this moral obligation that publicly funded research should be publicly available, and open science allows us to do that. It allows the work that we do, the research that we do, whether it's primary or secondary, to be verified or reproduced. So if someone wants to come along and check that what we did was actually feasible and obtains a vaguely similar result or similar direction of findings or magnitude of findings, someone can replicate what we've done, whether that's the actual research itself or the analysis. It also means that our research has a greater impact because it's more publicly accessible as a full text, for example. Um, and then by being more open, we're supporting a higher complexity, a higher level of analysis. If we think about primary research being fully open, it makes systematic reviews much easier, and that allows a higher level and a higher complexity and a higher power of analysis. And so collaborations in that way, thinking about open science as an ongoing passive in a way, collaboration is a real advantage. There are some perceived disadvantages that the research that we put out there, the things that we make open might be misused. They might be misunderstood. It might result in a proliferation of poor quality research. This was one of the concerns as open access was being pushed as a policy. And it can exacerbate power imbalance, meaning that the people who can afford time and the costs of open access are often a group of people who have power that others do not. So marginalized groups often don't have open access funding. They often don't have time to spend preparing all of their data. This is one of the sort of the disadvantages of it. So, it's not all easy and positive, and it's important to have these in mind as we think about open science and evidence synthesis. So, thinking about what open evidence synthesis, open synthesis means, it's important to take a step back and think about what closed synthesis means. And this is now a very old tweet from before Twitter went south, but I remember seeing this and chuckling. And it's actually, I've now had that experience myself, but you see it more often that people do make a request for data, as the authors say, data available from authors on reasonable request. And then that can be denied if there is a feeling of suspicion over the use, which is really far from open. But some of the problems with evidence synthesis, systematic reviews, and other literature reviews that are not open is that there can be, without being open, people can be selective or incomplete in what they're reporting in terms of their methods, but also their results. In general, there is a lack of methodological detail in traditional approaches to literature reviews. Paywalled articles for anybody who's here who does not have a library or institutional subscription, even with the majority of research being published today as open access, it's still very common to hit paywalls. Uh, and it then be very difficult to access the evidence synthesis we're interested in. Also, the fact that some publishers will present you with a payment option when that full text is in fact available online. It's only if you're signed in institutionally you get presented with that first up. For evidence syntheses that use meta-analysis, often historically at least, meta-analysis has been based on statistical software that isn't code driven. So even where it is code driven, often people don't provide their code because they're a bit nervous about that. And that can mean that it can be impossible to reproduce those meta-analyses. A lack of openness in systematic reviews can mean that the data are unclear, that it may have no metadata, so even if it's provided, we might not understand what it is because best practices in openness haven't been followed. It may be that the data are not usable. I'll come back to this a couple of times, but it's quite common that data are provided in a table in a PDF, which is then, for most people, very, very difficult to extract and then turn back into usable data. There's also where protocols are not made open or people don't publicly announce that they're doing research. That can lead to research waste because more than one group can be working on the same topic, or a lack of collaboration where collaboration could bring real strength. I'd say even in general, this is an issue that's really ongoing, that conflict of interests are not described and trying to push the community for openness, true openness in interests that might be conflicts or not is a problem, particularly for systematic reviews where often a review is needed because the topic is contentious. So being really clear about any potential conflicts is really important. And then where we're not open, there is a risk that decision makers might be misled by an assumption that it doesn't hold true about that literature review. Um, and then finally, one of the great things about systematic reviews is that they can be updated by just doing an additional small body of work on top for recent articles to allow new research to be included to see how things change over time. And if we are not being open in our evidence syntheses, that whole work of the evidence synthesis needs to be done from scratch. Um, and when you've done a systematic review, you know how much data there are. If you make that publicly available so that someone can update it, if you don't have the intention of doing so, that can then become a much more powerful piece of work because it can be done much easier, much swifter, and more efficiently. Um, yeah, so this graphic, I just ran a quick search in lens.org, which is an open access database of academic literature that's powered by a number of different data sources. And it has about 291 million records in, I think. And so I searched for systematic reviews or systematic maps just in a really brief search in abstract keywords, um, title abstract keywords and field of study. And we're probably all familiar with these exponential growths of evidence when you do a systematic review and you start performing searches. And so this is just confirming that pattern in lots of other fields as well, that the volume of systematic reviews is increasing exponentially. And you see, like last year, 105,000 systematic reviews were published in 1 year. It's nice to see that the majority of them now perhaps are open access, um, whereas, sort of 2010s, early 2010s, it was less than 50%. But that's still a large um, number of systematic reviews that are not being published open access. And so if we imagine this 105 systematic reviews, just in the field of medicine, there are 22,000. So this is probably the biggest subfield. But within medicine, that equates probably to an average of about 1.2 billion titles being screened across those 22,000 search results. That's taking into account average numbers of search results. And bear in mind, there are only 291,000 records in Lens. Other databases are even smaller, Scopus and Web of Science. So that's a huge amount of records. Loads of those must be overlapping, both just because of topic and just because of the volume of literature out there. There are not 1.2 billion records in existence. So there is a lot of those records have been read multiple times. This is the schematic that I used as a reference for those numbers. It's a study that we conducted quite a while ago now, 2017, where we were looking at the average volume of evidence and the time needed for each step of systematic reviews and systematic maps. But there is a huge overlap in the content within different subfields of primary records that are being screened. So sharing that workload, sharing that effort by being open presents a huge potential saving. And this just shows where those records lie within that the subfields. Lens.org, if you're not aware of it, is a really great database, if you don't have access to Scopus or Web of Science because of cost, because of a lack of institutional access, lens.org is a really friendly um, interface for conducting searching. So we, a while ago, came up with this idea of open synthesis, applying open science principles to evidence synthesis. And we came up with a framework, and I just wanted to spend a few minutes just talking that through. We came up with this idea of open opportunities for collaboration, perhaps. And these aren't things that will necessarily apply in every single case, but in a drive towards openness, this might be what we want to level the playing field and approach equitable communities of practice, really. Open discovery is what we defined as free to use bibliographic databases. Open methods being freely accessible and detailed methodology. Open data, freely accessible data associated with a systematic review. Open source, so if software has been adapted or produced bespoke for a review, then that software should be provided under open source. An ideal scenario might be that that software is provided open source so that it can be adapted and reused. Not just software, but also things like code for meta-analysis. So it's where there's a bit of a spectrum between functional code for analysis and functional code for performing some other task within a review. We also are aware of something of open access because it's probably the longest historically that's been around, free to access manuscripts. Ideally, open peer review, where the peer review reports can be seen and incremental changes because of those reviews can be seen as well. And open education, where resources to allow people to learn more about evidence synthesis and different aspects of systematic reviews and systematic maps can provide a benefit when they're provided free of charge. And then another one that we proposed was an open interest, so declarations of financial and non-financial interest being provided openly, perhaps independently of a review. There were other ones that were proposed by the working group, things like open metrics or open policy advice. These exist in open science, and particularly because of the positioning of evidence synthesis in its role in evidence-informed policy, open policy advice might be something that is sort of a natural next step. So thinking about why open synthesis is important in the first place, as I mentioned at the beginning before I got started, I think because we as evidence synthesists rely on primary research, we're aware of the stumbling blocks that we're faced with when a lot of the research we're synthesizing is not open. So as people who are faced with challenges from closed primary research, it really behoves us to bear that in mind when we are considering being open with systematic reviews that we write. Already, evidence synthesis is built on a lot of open science principles by its very nature. So as standard practice, we're used to providing protocols that outline our methodology, and the methodology of a systematic review is that central cornerstone to why they're more rigorous than traditional literature reviews. So we're aware of some of these principles. We might as well go all in. So things like open methods. But the issue is really this openness in our protocols hasn't been termed in it hasn't been provided in terms of open methods. It's been called protocols, but it is a form of open methods. So those linkages with open science haven't been explicit. And by linking with this community of practice around open science, those linkages can be just useful for both communities of practice. And as a result of that lack of linkages, the benefits haven't been fully appreciated. Um, as we talked about a bit already, evidence synthesis, um, the sort of average evidence synthesis that's published today is still insufficiently open. You still see things reading through systematic reviews, even ones that look particularly promising. There are still aspects that are not as open as they could be. Often those are small things. Sometimes they are big things that mean that for example, the list of included studies isn't provided. That's quite an easy thing to forget to provide, but without having a framework by which we're sort of assessed or guided, um, that then can cause some problems in terms of reliability or reusability. Um, and the idea behind open synthesis is that this framework of how to make reviews more open provides a framework that people can follow. It provides guidance, it provides standards, it provides help. And that then means better syntheses. A lot of this work around trying to be more open is not about a lot of additional new effort. It's files that might be on our computer. It's formats that, if we'd been given advice and guidance from the beginning, we could um, keep them in a more accessible format, and then being open is easier. So it's all about making things easier and better. So the benefits of being more transparent, more open, are that it facilitates full transparency. Transparency is a cornerstone of systematic reviews. It facilitates and permits verification of review results and conclusions, um, particularly in things like meta-analyses where people might want to replicate the code or have the code to replicate the analyses. By being really open, that just helps verification. I know Wolfgang Wichsbauer once told me that if he's peer reviewing a meta-analysis and the authors have provided their code and the raw data, he's immediately in a much better place to be able to peer review that article, and probably therefore in a better mood. Um, Similarly, it increases the reliability and trust in evidence synthesis. So if we are being more open, there is an assumption that we've got nothing to hide. It also, by being more open, we're making it easier for people to participate when they are in a constrained resource context, like a lower middle income country. Removing barriers to participation from people in resource constrained environments is really important. Um, it can facilitate um, data reuse. So if we're being open in our evidence synthesis, it allows people to then continue that spirit of openness. Um, by allowing someone to come along and use the data that we've extracted and the analyses that we've performed in a review, we're allowing people to stand on our shoulders and carry on, really. We're allowing other people to do work more efficiently. As we know from that exponential increase in the volume of published literature graph, the volumes of evidence that we're dealing with on a yearly basis are increasing substantially. So by being more open, we can really be helpful to future people, perhaps even future us, who may want to repeat or update our review. Um, and also, it is slightly annoying, not that it happens a lot, but it's slightly annoying to have to respond to requests for information from a closed article. So if you make your data publish, you just don't need to respond to those. I know it's one thing I do try to do is to log into ResearchGate and respond to requests for articles that unfortunately were paywalled, but I do try and do it. That is an effort, that is a cost in terms of time, and so by trying to be as open as possible means that we don't need to worry about that too much. Um, and it also gives us an opportunity of being open to raise awareness of rigorous evidence synthesis and build capacity. So through training materials in particular, but also allowing people to read them freely means more people will see them, more people will learn about them. And as a result, of all of these things, it can increase the impact of evidence syntheses. So as I said, and I mentioned some of these already, open science is not without its criticisms. I remember one of the first reviews I conducted, I'd asked a primary author for some data, and they said that what I was conducting in was research parasitism. I think that's sort of changed a bit. I know other people have had that response as well with a request to authors to reuse data. Um, I think that is changing now, but there is a view that it is a form of parasitism. It's not recognized as a research endeavor in its own right. And I've ordered these in what I think are from the sort of ridiculous up to the not so ridiculous. Some people are afraid of having repercussions if mistakes in their analyses are unearthed. Some people think there's a risk of misuse by providing data in particular in an open way, or that there's a risk of public misunderstanding if the public is allowed to read something that shouldn't be made available. Um, there is this fear that there's a proliferation of low quality science, and I don't think necessarily open science is the result of that. It's more about the incentives that are institutionally um, provided to researchers that cause that. It can, as we've seen from the exponential graph, perhaps contributes to information overload. But we can adapt, as we know, with AI coming into the discussions around evidence synthesis, that there are continued ways to adapt to that increase in volume. There is a cost of openness. I'm trying to publish a systematic review at the moment and cannot afford publication fees because I'm not affiliated, and unfortunately, my authors don't are either not affiliated or don't have an agreement. That is particularly the case for people from resource constraints and lower middle income countries. Um, Platform capitalism is a criticism where if they're not making money from charging people to see the articles or charging people for other things, they'll make it some other way. Um, Open science can exacerbate power imbalances, inequality, minorities who are excluded or marginalized, as I mentioned, particularly people who don't have time or money to spend a lot of time in openness. Some people, particularly in social science, think that openness is incompatible with confidentiality. So to be truly open in social science, we might be theoretically forced to publish all of our interview transcripts, which is obviously not safe and obviously not something we would do. And so ideas and practices around openness there need to adapt a little bit. But in particular, career incentives that are in major institutions have not been tailored towards openness. They're tailored towards rewarding closed practices, but particularly penalizing open ones. And there is a risk with systematic reviews in particular, there's a risk that people can mistake openness with rigor of conduct. And the other way, that if you read a review that is not open, it doesn't necessarily mean it's bad, it's just very difficult to tell. So just a few modes of mitigation for some of these problems. Um, Actually, by being transparent and providing clarity, we can avoid misunderstandings. Um, we can reward self-corrective behaviors like corrections and retractions to avoid fear of punishment. Um, I feel like the research community is accepting replication and validation as part of science now. It is still seen as a sort of different thing that's done independently, but it is being a little bit more rewarded now. Um, and this idea of post-publication peer review is something that is ongoing with services like PubPeer. We can raise awareness around reporting standards like Prisma and Roses and try and get more people to adopt them, which push for openness in an easy way, so making it accessible. We can continue to develop and highlight low cost and free tools to support various aspects of openness. We can try to normalize budgeting and planning for open practices, both in terms of time and money, um, and trying to get that into equitable funding that provides funding for people who can't afford it. Institutionalizing training in openness as well, and establishing best practices for anonymizing and summarizing data in response to the worry about particularly social science interview transcripts, and then provide general support for researchers in resource constrained contexts, which you do see around waivers, but could be a lot better. And thinking about how we achieve it, this is something from the Center for Open Science, and it's not something that can happen overnight. There is a way to get to the point where you make it necessary, you make it required. You first have to make it possible, then you have to make it easy. You have to make it normative so that people are doing it and expect everybody to do it, and make it rewarding. I'd sort of argue that those are the other way around, actually. And only then can you really make it required. But you need all of those steps to be able to change research culture like open synthesis. And so some of the tools that we can use to some of the things that we can use to achieve open synthesis are tools like lens.org or OpenAlex that I've explained around open searching. Repositories for data, method, and code. If you're not using them, they're free and great. Things like Open Science Framework, Zenodo, and GitHub. Executable research articles are a really nice way of uh, using code to produce a document so that the figures and everything behind it are examinable and verifiable. R Markdown is one tool that might be familiar to some of you. Resources where you can go to find information about tools that are available, like Systematic Review Toolbox, and a shameless plug for the ES Hackathon. And thinking about interoperability, which is sometimes okay around RIS files. We can move between different tools, but that's something that I think will improve the system by allowing people to move out. You allow people to choose which tool they want to get familiar with at any point rather than being stuck in one. We should have standards for machine readable data within systematic reviews so that people aren't publishing tables of data in PDFs. We've got standards for data formats that can then be reused between reviews. And those are in interoperable file formats. To some extent, the amount of data and the format of data is prescribed in reporting standards like ROSES and to a lesser extent in Prisma, but those can help to achieve open synthesis. And then by having diverse voices, so people from low and middle income countries and resource constrained contexts are vital for ensuring openness. So a lot of web-based tools, or rather a lot of the landscape of systematic review tools require a stable internet connection. I've done a lot of training in contexts where the internet drops out, electricity drops out, and so building those considerations into preventing people from getting stuck is important. And having a leave no one behind attitude here, I think, is really important. This is just a schematic I put up to highlight that there are hard aspects of institutionalizing a behavior. This actually comes from the world of human resources, but there are strategy, structures, and systems in place that can support adoption of practices like open synthesis and rigorous evidence synthesis. And then there are soft elements which are around the community of practice. And then thinking about practically what we can do as individuals, which is some of this is slightly repetitive, so I won't spend too much on it. But it just highlights the need to have these reporting standards to make sure that we are being as open as possible and continue to develop these standards so that they adapt to changes in methodology and make it easier and easier for people to use them. Hopefully, we're all at a stage where we are publishing our protocols, um, but doing that is continues to be really important. Um, Crediting information specialists with authorship is also really important. A lot of information specialists get involved and then get forgotten, um, and that transparency is really important. Um, and we can solicit and respond to feedback transparently, being open about what feedback on our protocol and plans in our review was taken into consideration. It's just a screenshot of the Roses Reporting Standards website. Um, in terms of searching, we can move to favoring open databases like lens.org and OpenAlex. Um, Lens.org, I don't know if OpenAlex does this, allows you to take a link for a search, and that URL is then a static record of that search. That is a standard, really great example of openness in searching. Doing the same thing in traditional databases like Scopus or Web of Science is very difficult, requires an institutional connection, if not impossible. There are other tools like Search Archive where you can archive a record of your search, like this one, and then you get a DOI. That that level of openness is great. It then allows a sort of push button replication of a search strategy. In terms of screening, you can plan your data archiving around openness. So if you already plan from the beginning to be providing lists of exclusion reasons, the way that you conduct that makes it a lot easier to then be open at the end. But bearing that in mind, most review management software allows you to export a standard interoperable file, either an RIS file that's annotated or an Excel file, for example, that has those decisions in it. And as I mentioned before, it's not unheard of for people to not publish their list of included studies, but if they do, sometimes it's as a static list in a PDF. And think about usability there. That is a lot easier to reuse if it's provided as an RIS file. Um, and then in terms of data extraction, we should always be providing metadata, which describes our data, not just providing columns without any context. It should be in usable formats again, and not as static PDFs, which are then very difficult, if not impossible, to extract. Thinking about usability and interoperability, providing a standard identifier rather than just a citation, like a DOI, makes things much easier to then reuse. I think increasingly people are moving towards tools like R for visualization and analysis. And if you're producing code, you can think about writing your code in a way that you're planning to make it open. And I think a lot of people are worried about publishing their code because they think it's messy or not great. If it works, it's fine. I don't think people will be at all critical. Um, it's also worth it publishing your analysis in an independent repository like GitHub, um, as well as in supplementary files. But that then allows people to interrogate what you've done. I mentioned executable formats like R Markdown before. They are much easier for us as reviewers if we keep a format that we can just redo at the touch of a button rather than having to copy and paste figures back into a static file. Um, and then at publication, we've got to remember to cite our protocols in our final reports, somehow linking the protocol to the report to make sure that the DOIs are connected. We should think about publishing preprints, so making our reviews available before they've been through peer review, clearly stated as a preprint. We can solicit and respond to feedback transparently, whether informally or formally, through peer review, public peer review, for example. Always think about gold open access, but I'm sure where you have funds, you already are. It's also worth self-archiving a final version of our report with all of the files, as well as on a journal so that it is available in multiple sources. It's not unheard of for journals to go out of action. And to remember that supplementary files typically have no size limit, so we can really go crazy in providing as much detail as we want there. So just to summarize what we've talked about the application of open science principles and evidence synthesis and reasons that we should be doing it. Primarily because it should be second nature to us as systematic reviewers. We talked about why, we talked about what it is and how we should be going about doing it. And we talked about some of the institutional and personal practices that I'd like to see in trying to move towards more open and rigorous synthesis. So that's it from me.
Thank you, Neil. I really enjoyed that. It's interesting how some things have changed, some things have really not changed over the past many, many years, and also how applicable a lot of what you said is also to the primary research. Um, Nothing rings truer for me than please don't put your data only in a table in PDFs. How am I supposed to use it? For those who don't know, that's actually why we built SysRev way back when, is because we had this problem with primary research that now folks have with reusing systematic review data. And it's interesting. Um, Please remember everyone to put questions in the chat. Until then, I'll just freeform some. Um, it's interesting also how much you talk about research redundancy sounds a little too harsh. But I think about this even with our own application. How many times has an individual article been reviewed? How many times has the exact same pieces of information been extracted from the same article? You could imagine a world where someone logs in, you start reviewing an article, and it says, hey, this has been reviewed in other public projects. Would you like to see what they extracted? Um, it's something I've thought about. It's obviously not something we've moved towards, but kind of stepping back, has there been any progress towards creating a data sharing infrastructure for evidence synthesis, or is that something that really is still a undeveloped or underdeveloped, if not non-developed kind of space?
I mean, it's a really good question. It's something that I know a lot of people have been talking about and thinking about the sort of infrastructural barriers are the hardest thing there. I mean, I spoke to a few guys working in a bibliographic database, and when you start thinking about adding layers of information, like every time an article's been reviewed, you've got a link from that article to its reviewing article. It's an
Hmm.
extra layer that it doesn't just add one more bit of data, like it adds a whole hierarchy. So it immediately gets much more complicated. I mean, as you know, right? But um, there is a real desire to do it. A while ago, I thought about piggybacking JSON data inside of an RIS file, which you can do. The RIS files do bloat quite quickly, but they already can be quite big. So I think people can immediately think about ways that you can, once you've got a unique identifier like a DOI for an article, about how you can link that to loads of other information. So it's something people can immediately think about what you could do with it and how you could use it. But the infrastructure underlying is the sort of, I think, the main barrier.
Well, in the
One example being that DOIs are frequently wrong. In Scopus, something like there was an article maybe about um, or an analysis, I'm not sure if it was published about 5 years ago, that showed that 15% of Scopus DOIs are wrong. And the ones where it's most frequently wrong were special issues. So the special issue just
mm.
got all the same DOI. So it was an entry error. Um, and 3% wrong in Web of Science at the time, which was unrelated. So, I remember speaking to someone who was developing a tool to deduplicate, and they were deduplicating on DOIs and just deleted any multiple DOI. And whilst that might be okay, like the risk of throwing away a large number of incorrect DOIs, um, yeah,
As
there are so many problems with data, right?
as someone who thinks a lot about the proper way to deduplicate and to merge, other than to have a human go and review and ensure that these are actually the same article, you are preaching. But it's interesting because the problem is also very one way almost, right? Like it's very easy for us if the RIS file has the DOIs for each article, assuming that they're correct, to include that and pass that forward. The difficulty is starting at the data and saying, okay, what are all of the pieces of information that have been extracted from this one DOI, right? It's easy for me to say this data came from this DOI, but what other data did? We could do that within sysrev, but unless we had a list of, again, every data point
So
and the
incomplete.
DOI from whence it was reviewed and all the different platforms said, here it is, how do you actually begin to unite that?
Yeah.
Um, again,
And
it's, go
one
ahead.
practical example is that is uh, if you're doing an umbrella review where you're reviewing systematic reviews on the same topic, um, finding out if your systematic reviews overlap is incredibly difficult because most of them don't provide a list of included studies. It might be in their reference list, that might be a different reference list, it might be the bibliography. Frequently, it's not provided. I've been in a few where it was impossible. We didn't have the time. It would have been days and days and days of work to go through all of the reviews and manually work out or contact the authors to work out what the reviews were, what
And
the articles that they included were.
that's just interesting to me. So for folks on the call, my background is more software than actual review methodology. But just from my point of view, why would you not always include as much information? If I were doing a review, surely the articles that I included in said review is a very important piece of information for any folk who want to come after, whether that's to add to, right? Like living reviews can be passed off, or just to check my work. It seems like perhaps the most important part.
It does.
But
There's two reasons it doesn't happen. One is that you often don't cite the reviews. Like just practically, if you're citing as you write and you're doing a meta-analysis, um, if you've got 100 studies in your meta-analysis, you're not describing each one in turn. You're synthesizing the body of evidence, so you never actually cite them. And the other is a lot of journals won't let you. They just won't let you have bibliographies that long. And so when it's optional to include it and dissuaded institutionally from having a table at the end where you cite them all and then them appearing in your bibliography, it's really easy to forget to do that. Um,
avoiding
so
soapboxes, it's just an interesting perspective. I perhaps understand it when things were only in print, or you only have so many pages. But in the world where anything can be a
no, it
link
makes
to a
no
new
sense.
page or a downloadable file, yeah. I'm quite familiar with cloud costs. I don't know that I buy that argument, but it's interesting that that's the one that they make. Now, there's something kind of similar though. You often see in systematic reviews during, or I'm sorry, rather in the data accessibility statement that no new data was created in this review.
Yeah,
And I think that's quite, it's an interesting perspective, right? Because from my point of view, when we're doing this type of thing, we're creating a lot of data and we're creating a lot of data that we can use in a lot of interesting ways. How do we begin to kind of change that mental framework that this isn't new data? Because at least from my point of view, it very much is.
I think it is changing. I recognize a change from when I started in the early 2010s that people are seeing it as a means of generating data and a research output in its own right. Um, I think it's lumpy in its change in that the people who are recognizing and appreciating that change are maybe not the ones in positions of power like editors and journal editors and people in those positions of power. I just tried to submit an article the other day and had a data statement, and it was like, oh no, you don't need one, you're a review. And I was like, no, I've got to put it in, and it physically wouldn't let me because I'd selected a review. So I think, yeah, one way is to just try to reach editors, but they tend to be senior, later career stage people. So waiting for people to move through is going to be a bit slow.
Hmm. So I've been poked that I should probably start wrapping, but I want to sneak in one more question. With all things AI, specifically Gen AI, any words of advice on how folk can use those tools in a transparent way and in a safe way?
Um, with 2 minutes left. Thanks, TJ. That's a really good question.
We can save it for next time, which will be a great segue to my only slide, which is that we have two more webinars in this series. Perhaps we can talk about it more then. How's that sound?
Yeah, I think so. Good deflect.
Okay. Hopefully y'all see a slide with the QR code. This is just a friendly reminder that there are indeed two more webinars in this series. The next one will be November 24th, the second one at December 11th. Please join us if you have not already registered. I hope you enjoyed this session. I know that I really did. And thank you again, Neal. Really appreciate your time and your energy in this.
You're very welcome. It's been a privilege. Thanks very much, everyone.
Cheers, y'all.